Last up in our section of trigonometric identities is the half-angle identities. These are also sort of useful in conjunction with the sum and difference identities in doing a similar process of finding an exact, say, sine of a half angle. So in this video, I wanted to talk about, well, why are these true? And then how do we actually use them and kind of compare to previous methods of doing so. So, but basically, if I'm looking at the half angle identities, what it says is that the sine of u over 2 is equal to plus or minus 1 minus cosine of u over 2. So in a similar way, we refer to these as double angle identities because it's sine of twice x. Here we have sine of half u, or half x. So it's going to, excuse me, give us, well, what happens if I'm talking about half an angle? And how we can use these is, say, for example, we wanted to find the sine of 22.5 degrees. What I could consider is, well, this is half of 45. And that's exactly how we use these identities is, well, what if I wanted to find this sine of half of 45? It would relate to, well, as the formula says, the square root of 1 minus the cosine of the initial angle divided by 2. And these are true exactly from the same reason that that these are true. So actually, if I make a simple u substitution in my power reducing identity, let's say that 2x is equal to u. Basically, I'm going to take this side over here and change that into just a singular u. And well, what that would imply about x is that x is equal to u divided by 2, which is what would leave me with exactly this idea. And applying a substitution is fine because x was a generic, x could have been anything, and I'm just saying that u is half of whatever x is. So it should still be true if I just change x to u in the form of this substitution. But this would leave me with the sine squared, the sine squared of u over 2 is equal to 1/2 times 1 minus the cosine of u after applying that u substitution. Sorry, you could not see what I was writing, but I was just taking exactly the power reducing identity for sine and applying that u substitution. But now, basically, since I have sine squared, another generic algebraic principle is that if I have a square, I could take the square root of both sides. And if I do that, that would cancel out the square root. Well, technically, it's not necessarily going to be that simple because when I'm taking the square root of something squared, that would leave me with the absolute value. Whoops, I don't want to use blue here. That would leave me with the absolute value of sine of u over 2. Because remember that the square root of something squared, the problem with something squared is that it could have been positive or negative and we don't know. So the square root symbol always leaves me with a positive answer. So whether or not this was positive or negative, it could have been either is the point. And then on the right-hand side, I'm left with the square root of, and if I distribute that, it'll be 1 minus cosine u over 2. And basically, since I didn't really know if this was positive or negative, I could apply the algebraic rule for absolute values, which is plus or minus. Or as as my algebra teacher used to phrase it, is taking the square root of something squared gives you a plus or minus always. It's a rule which you could remember, but the sense of that is that sine could have been negative 1/2 or positive 1/2, and ultimately we would not have known if it was squared. So when we're taking the square root, it could be positive or negative. But basically, this gives us what our half angle identity for sine. In the next video, we'll talk about actually using it and how to solve half angles.